Assalamualaikum, good day and konnichiwa to all ICIMECE 2020 participants and organizing committees. I'm Nurhazimah Nazmi from Malaysia Japan International Institute of Technology, MJIIT University Technology Malaysia UTM. Before I begin, I would like to thank to the organizing committees for invited me to be one of the speaker. Today, I would like to share a research on gait event detection using machine learning approach. According to National Stroke Association of Malaysia (NASAM), stroke is the third largest cause of death in Malaysia, and approximately 40,000 people in Malaysia have suffered from stroke. What is stroke? Stroke is a brain attack and occurs when the blood supply to the brain is disrupted. It will affect physical, emotion, and cognition. For physical, there is a symptoms known as foot drop. Do you know foot drop symptom? Foot drop symptom unable to control the ankle movement inward and outward, as shown in the video. In other words, they are suffered from uncontrolled plantar flexion and dysfunctional dorsiflexion. As foot drop patient can't control the ankle movement, it will affect the gait pattern. It can seem that the difference on normal person and foot drop patient, especially during swing phase. In order to recover the swing phase of foot drop patient, this could be done through rehabilitation. Rehabilitation is a major therapeutic approach as the motor performance functional deficits of patient can be maximized and minimized. Generally, physiotherapy and rehabilitation are carried out through repeating the exercises many times with the assistance of one or more physiotherapists. One of the assistive devices, namely ankle foot orthoses, had been demonstrated improve the gait pattern of foot drop patients through rehabilitation. Various AFO had been developed with different types of controller. Recent studies have developed AFO using electromyography, EMG signals, and ankle angle. One of the studies considered the EMG force model in order to control the actuator of AFO. Other study had considered the classification of EMG signals to control the brake of AFO. However, EMG signals are stochastic and complex as it were influenced by anatomical and physiological properties of muscles. Therefore, analysis of classification EMG signals are important in order to control the actuator. What is EMG? EMG is an experiment-based method for evaluating and recording a series of electrical signals that emanate from body muscles. The electrical of neuromuscular activation generated in muscle during contraction and or relaxation is known as EMG signals. In order to classify the gait event, foot switch data had been used as a reference. The detection of EMG signals were recorded on two muscles. Afterwards, an analog digital converters was connected to EMG and foot switch devices to collect the data. In signal processing, there are 5 stages: raw signals, pre-processing, feature extraction, classification, and controller. However, the classification is the main crucial stage in order to achieve a higher or better classification performance. For classification, machine learning is widely adopted in the study of EMG signals. Machine learning is not only proven to be a powerful tool for learning the biosignal of the experimental data, but as well as to predict the unlearned data. Machine learning, such as artificial neural network (ANN), are able to establish the relationship between the experimental data and the model. It also have 3 layers, namely input layer, hidden layer, and output layer. It's also based on the multi-layer perceptron type. For ANN model, 10 hidden neurons are considered since it performs better than 20 and 30 hidden neurons. Different number of inputs and training algorithm also influence the performance of ANN model. In order to develop the ANN model, initially, the gate phases were detected based on foot switch data. MATLAB software was used to design an algorithm to recognize the timings of gate pattern and the EMG signals on 2 muscles. The data set of EMG signals were divided into learned data and unlearned data. Learned data were used to design the ANN model with different configuration such as number of inputs and training algorithm, namely Levenberg-Marquardt and skill conjugate. The ANN model with the highest accuracy had been selected to predict the learned and unlearned data of gate event through Simulink. This is the confusion matrix of the highest accuracy of ANN model. The detection of gate phases using this model, ANN model, were compared with the foot switch data. The dotted line represents the prediction from ANN model. Meanwhile, the straight line is recorded from foot switch data. The time difference of the detection for gate event for both are compared. For figure A, the time difference between event detected by ANN and foot switch for learned data. For learned data, the time average difference are in the range between 16 milliseconds and 21 milliseconds. Meanwhile, the average time difference from unlearned data in figure B, the difference are from 35 milliseconds to 49 milliseconds. It can see that there is very small difference from ANN model and foot switch data. Then, the model accuracy have been evaluated with the Wilcoxon sign rank test. Based on the test, the null hypotheses are accepted as the p-value is greater than 0.05, which implies there's no significant difference between foot switch data and ANN model. The result had shown that the ANN model has successfully classified the gate event with higher accuracy, and machine learning had proven to give a promising result for classification of EMG signals. The outcome of this study could enhance the development of ankle foot orthosis AFO, and implementation in real-time application was suggested for future application. So I think that's all for me. Thank you for your attention.